let's see. Make sure everything's on. All right, ladies and gentlemen. Sorry for the late start. There was a department meeting, and here we go. Here it is. Trying to get through my notes here. All right, well, see what I can do here. Just clearing up some notes here for you guys to start the work for today. Here it is. Okay. So what section are you guys in? Do you guys remember? Your section what? Are you 1-3? What is your section? 1-3, what's that? Let's find that out. One 6408. Okay, hypothesis testing about a proportion. So this is the unit we're starting here, hypothesis testing. Now, if I go to my website, I want you guys to know here under 227, elementary statistics, video library, table of contents. Hypothesis testing. And this is where we're looking at now, just so you guys can see that, table of contents. And here we go. So let's give you guys some information here. What is a hypothesis? So if you guys remember, or maybe we'll start off by asking you this question. What do you think a hypothesis actually is? What's a hypothesis? Did you guys ever hear that phrase before? What does that even mean, a hypothesis? What's a hypothesis? It's an educated what? Guess. So in English, if you take an English course, a hypothesis is known as an educated guess. And you say it's an educated guess about what? In statistics, this course, it's an educated guess about a population parameter. So what is a population parameter, by the way? No, this is a hypothesis. What is that? Do you guys know? What are the parameters? They are what? P. What else? Mu. Sigma squared and sigma. So this is going to be a P stands for proportion, ladies and gentlemen. And it's the same P you guys worked with estimation. These are the true values, okay? So if you said, what are these things? They're the true values. Right? So here we go. Proportion. Mu is what? A mean. Sigma squared is what? A variance, and the sigma is a standard deviation. These are all those values you guys worked on in the past, okay? So what we're going to start really is hypothesis testing, in case you guys didn't know. That's the name of what we're going to start to work with. This is code for the scientific method. Okay? This is our scientific method. So there we go. Hypothesis, educated guess about a population parameter. True values, P for proportion, mu for mean, sigma squared is variance, sigma standard deviation. So here's the deal. right? So what you want to do now is this. This is what we're going to focus on. This is really the first step. Hypothesis testing, we got that first step. The first step is to show you guys examples of what we mean by hypotheses, right? So what if I said to you guys here, I'm gonna write down this statement here, okay? I'm gonna say the proportion of students who sleep till noon. I'm not saying this is you guys, and we're gonna say the proportion of what? College students who sleep till noon is, what do you guys think? Any college student sleep till noon is about what? Is 25%. All right? So the proportion here is given by the parameter we call what? P. So P stands for proportion. That's the same proportion you guys did with estimation. Okay, it's a population parameter. And so the proportion of college students who sleep till noon, you guys know what the word is means? What does the word is? If I say, let's go back to some phrases. We're going to work with some key phrases here, okay? Is short for what? Let's go do a little bit of some S. You say, what's some S? Let's do some math. You go, math. Math phrases. I'm going to say, here's a symbol, okay? Is. What's the symbol for is? You guys remember? What math symbol is associated with the word is? Anybody know? What is it? Equal. Good job. Thank you. It is the equal sign. You guys okay with that? So in this example, when they say is, and they say it is equal to 25%, what do you guys think? What is that? P equals what? 25%. You guys okay with that? All right, there it is. So you got the math phrase is, and the symbol is what? Equals. All right, math phrase. Now, that's a phrase. We're gonna do some more phrases. You guys okay with that? So what you're looking at is what we call a hypothesis. P equals what? 25%. Is that easy? All right. Let's give you guys another example. What if they say the proportion of students who what? Who drink coffee every day, because that's what it means. What if we say is not what? 50%. Okay? Here's going to be another example of a hypothesis. What do they mean by the proportion? What do they say? What parameter represents a proportion? Do you guys know? What letter, I should say? Proportion. See this true proportion? What letter do we use? We use P? Then what's this phrase? Is not. You say is not what? 50%. So when I translate this phrase, what does that mean about P? P, what's the story? Well, what is the phrase is not? That's the same as what? Yes, that's not equal. Good. It's not equal. Good. So you can say is not equal to what? 50%. Mm-hmm. So when we write this down here, we have is, we have what? Is not. You want to know that phrase is not equal. Okay? So I want to make sure you guys know every one of those particular phrases has a what? Has a symbol. P is not equal to 50. Okay, so far so good. And by the way, do you guys happen to know what is a proportion anyway? Just going to give you guys a note. Because you might even say, hey, Mr. Judge, I don't even know what a proportion is. Well, okay, I want to put that as a note here. When you see that word proportion, that's a general term. What does that general term mean? For what? For what? A proportion is known as a, that's really like a percent or what? Or probability. Proportion, percent or probability. So ladies and gentlemen, there you go. You guys with me? All right. So you guys know about that. And so the population proportion, P though, which we're going to start with, is defined to be X over what? N. So do you guys remember what X is? X is the number of successes. And big N is the population size. So that's if you take a census. It's big N. Okay? All right, you guys okay with that? All right. What else do we have here? Okay, I'm going to let you guys know what's going on here with that. So if you said, I don't even know what a proportion is. Well, that's stuff we've been working with, a probability or a percent. But it's from a population. Okay, compared to, by the way, since we're on the topic, you had a test on this. Right? If this is your population and you're gathering data values, what we're going to use today is this information. What about, ladies and gentlemen, a sample proportion? You take a sample. Do you guys remember that? So even on your test, we had that sample proportion. It's a very similar definition. So your sample proportion, P hat equals what? X over N. There's your sample proportion. X is the number of successes. N is the sample size. All right, the proportion of students who drink coffee every day is not 50%. All right. So there's another example. I'm going to give you guys another example here. So I just want to give you some clarification. And then if you said, do you have this on your notes? If I go back to my website, right, I want you guys to understand something here. I do have something called hypothesis testing notes. You can actually, use that. This is what we're kind of going through here, just so you guys know, okay? But I'm giving you guys a different lecture. And not there. Where are you guys? You're right here. But okay, let's go back to what a hypothesis is, right? Yeah. Let's go back. So here's another example of a hypothesis. They can say the proportion of California residents who live to be, let's say, 80 years old is more than, we're going to use that, is more than 12%. So we're going to go out of the college student setting. We're just going to now talk about California residents. So here's your proportion here. Proportion what? P. So the proportion P, California residents who live to be 80 years old is, what's this phrase? More than what? 12%. So ladies and gentlemen, what do? You write this down as what? P greater than what? 12%. Do you guys know why we have to use greater than? Yes, you see the phrase more than? Isn't this all the phrases we were used to using? So the good news is, ladies and gentlemen, these are phrases that we're familiar with. I'm going to write that down here. More than is what? Is greater than. So here we go. All right. How about this? The proportion of students who what? Let's say smoke. I'm not going to say what they smoke. And that's again college students, not high school or middle school, is less than, I'll say, 20% now. Okay? This is another example of hypothesis. We're going to have to go through this hypothesis example. Proportion what? P. What's this? Less than. Less than what? Let's find the highlighter. Less than what number? 20%. P less than what? 20%. So you guys have that less than sign. So if we go over here, you're now going to use what? Less than, which is what? Smaller than.
It's like the arrows you would see at the elevator.
What's that?
The arrow signs.
Yeah, that's a less than symbol. So do you guys remember these symbols from high school? The language in these symbols. This is all the symbols. So these are kind of back. So it's kind of good stuff, ladies and gentlemen. These are all hypotheses about proportions. So I'm going to give that to you guys here.
see we got a reunion.
What's that?
It's good to see we got a reunion.
Yeah, it's kind of like a review of some of these ideas. You know, hypothesis testing is amazing. All right, let's give you guys some more language. There's only two more, but okay. I don't know if I want to ask you guys this question, but maybe if I say the proportion of students, college students again, who favor, you know, college students, who what? Who own, I'll say that, who own a PS what? 5. Okay, is no more than, what do you guys think? Do you guys like the PS5? Too expensive? PS5? You like Xbox better? Which is better, PS5 or Xbox?
I grew up with Xbox.
Yeah, I know. I keep asking these kind of questions in classes for students. There's always this big fight, Xbox or PS5.
It's because one has more games than the other, but one has kind of like more affordable pricing with the chance of getting to play some games for free without even have to buy the disc.
Yeah, I don't know.
Because you have to like buy the Game Pass in order to play these games. But on a on a PlayStation system, you can just buy the game and there you go. You don't have to buy the Game Pass in order to play whatever. You know.
Yeah, I don't know. There's various marketing. There's various marketing. So you got the proportion of cost to own a PS5. Let's say it's more than, I don't know, 30% or 35%. And I don't know, like I said, I'm making these up because my focus is on the language. Right? Remember I say, what's the hardest part of statistics? Language and process. So no more than, what do you think that's going to be? No more than. You guys already know, we've been working with the language for a long time. You've had it like from the first week. Did you guys know that? Week 1, this language, this is what I keep saying. I've gone over the language over and over again for you. And the parameter for proportion is going to be what? P and 35%. What do you think no more than actually is? How do we represent no more than? Is that less than or equal? It's no more than.
Just no more than.
Yeah, it's less than or equal. So it's like saying 35% is the limit, right? It's 35% or less. So remember that, because this sometimes helps me. It's equal or it's less than or equal. So I'm going to put that on our list here, okay? The no more than. No what? More than. Isn't that less than or equal? I'm going to kind of write these down here. Let's highlight those. Okay. Another example. So what if I say this one? How about this? The proportion, let's really make people mad, right?
So
That's really, Xbox versus PS5, you guys don't know how many arguments people have had. The proportion of college students who own the Xbox X. You guys like the Xbox? Isn't that what it is, Xbox X?
Xbox X and X.
Xbox 10, is that what it is? I don't know.
I just call it X. Yeah. But they just rebranded.
Do you guys like that? Xbox X or PlayStation? PS5?
Xbox.
I think a lot of people are used to Xbox, but I find there's a lot of Sony lovers out there. There's a lot of PS5. They just love that PS5.
Better
I don't know. I don't know. I don't know. Is it which one has better graphics?
The PS5.
Does it really?
Yeah.
They have Ubisoft graphics where it makes the games look like realistic and everything.
Yeah. No,
And
that.
Xbox has something similar to it, but not too much.
Oh, I don't know. See,
It's got ray tracing too.
it's interesting. I don't know these things. And I just got an Xbox X.
Xbox S?
X, not the S one. I got the new one.
Those are expensive.
They are expensive. They're too expensive.
Let's play together.
I know. So like, I just got it because my daughter likes to play, and
We'll play Minecraft together.
she's see, my daughter likes to play. So the proportion of students who own an Xbox X, I'm gonna say is at least, I don't know, at least what? 30%. Okay. Now I want you guys to compare and contrast the language. This is the whole point. What does at least mean? Do you guys know? How do you write at least? P is going to be what? Greater than or equal to what? 30%. At least 30%. So, here we go. Greater than or equal. So what I want you guys to know and to keep in your notes is these symbols. What in the world do those phrases mean? Okay? Is not the same as, more than, less than, no more than, at least. These phrases are there. All right?
Looks like I'm mining for gold.
Okay, these are some examples. What do you guys think? Is that easy peasy lemon squeezy?
Yes, sir.
Guys, what do you think about this? These are all what we call hypotheses. So I want to give you guys a fact and more definitions. So here's a fact. We have two types of hypotheses. Okay, there's two types. So I'm going to give you two definitions here. It's a really simple thing, but it doesn't sound like it when you first read this. So we have a null hypothesis. So the null hypothesis is a what? Is a hypothesis that involves a condition of equality. Okay, and that's the symbol of the null hypothesis. And you say, what do you mean? And I'm going to color it different. I'm going to give it an orange color. Okay, so you guys know what that is. Null hypothesis, there you go. A hypothesis that involves a condition of what? Equality. So let's ask you, which involves a condition of equality? Where do you have it? Which one of these hypotheses have equality? Because I'm going to write this down in case you guys didn't notice. Okay? All of those symbols, we had equal, right? What else do we have? Not equal, greater than, less than, greater than or equal, less than or equal. So when they talk about the condition of equality, what I want you to know, which one of these symbols involves an equal sign? Equal. Equal. What? Equal. You with me on that? So any hypothesis that involves the equal sign, called a condition of equality, will be considered a null hypothesis. There it is. Okay. Definition of the what? Alternate what? Hypothesis. It's a hypothesis that does not involve a condition of equality. So there's the alternate. And you say, what's the lack of condition of equality, right? You say, what do you mean? Does not involve a condition of equality. What does not involve equality? Not equal, that's not equality. Does that make sense? What about greater than? Is there any equality in greater than? Say what? No. What about less than? Is there any equality in less than? No. So where there is no equality, we consider that a what? Alternate hypothesis. There it is. All right, you guys okay with that? There's the deal here. Yes. Question? Nope.
Oh, no,
You're good with that?
just searching.
So let's go back and look at every one of these here. You see this here? See our first example? You guys tell me, what kind of hypothesis is that first example? What are you going to say? It's H what? Does it have a condition of equality? What do you guys think? Is there equal here? So call that H naught. That is a null what? What color was null? Orange? This is a null hypothesis, okay? I want you guys to see that. Because of the condition of what? Equality. Can you guys see that? All right. What about this? So why is that an alternate hypothesis? Because this is not equal. All right, you guys okay with that? All right, what about this over here? Right? H what? Is that a null or is that an alternate? Is that a null or is that an alternate? Does it have a condition of equality? Is there any equal for greater than? Nope. So that's a what? Alternate hypothesis. So any hypothesis that does not have equality is called an alternate hypothesis. So you guys okay with that? What do you think? Okay? Alrighty. So what's this going to be? Is this a null or is it an alternate? Look at the inequality. Is there any equal sign there? Do you guys have an equal sign for strictly less than? Say what? No, so this will be an H1. All right. There it is. Over here. What's this? Is there a condition of equality here? Yes, there is. You say, how do we know? Because that's less than or what? It's less than or equal. Less than or equal. So this is a less than or equal. So is that a null or is that an alternate? I got to wake up. It's an alternate.
The other one's the same thing.
Hmm?
The other one's the same thing.
Well, be careful. Do you see the equality sign here?
Yeah.
Then the second you have the equal, the possibility of equal, because that's less than or equal, that makes that a null hypothesis. The prior example was just a less than. There is no equal, so that makes it an alternate hypothesis. You guys good with that?
I was talking about the one at the bottom. Right? Wait,
Oh, I don't know.
There is no other one at the bottom. Never mind.
Well, there's one more. Here it is. Here's the last one.
Oh yeah, there is. Never mind.
There is one more. So let's ask you, is there a condition of equality here?
Yeah.
What do you guys think? Is that one? There is. So this is going to be what? Greater than or equal. So we're going to call that one H what? H naught. It's H naught because it has a condition of what? Equality. Why? This is the greater than or what? Equal. Greater than or equal. So you have it here, the definition of what we call a null and the definition of what we call a what? Alternate what? Hypothesis. And the orange is the nulls. And you might say, why is it a null? Because the condition of equality, this equal, this equal, this equal. That's what makes it a null. If it doesn't have equal, you call it a what? It's an alternate hypothesis. Okay? Easy peasy lemon squeezy?
See.
Alrighty. Here we go. All right. I think, let me go back now. Let me say this to you guys. You know what we're ready to do? I'm going to give you this procedure here. Everything that I went through with you, I'm going to say is here in these notes. Okay. So I just want to go scroll all the way down. I'm going to go through this guideline for hypothesis testing, right? So we've actually talked about some of these things. And you're going to see the procedure here. But we're going to start with what we call a two-tailed test. And so I'm going to illustrate the hypothesis testing procedure. When you first see this, it's a bit long, I admit, but you want to know something. It gets easier and shorter the more you practice. So it's just practice, 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 okay? This is a formal scientific procedure. So I'm going to go all the way down over here, ladies and gentlemen. We're going to have something called a significance level or level of significance. It's going to be called alpha. So I want you guys to know this is something that's a part of our process, and that's going to be the probability of rejecting H naught when it's actually true. We're going to talk about this. We're not going to talk about that in great detail yet, but we will go over it. And traditionally, you had to use what was called a z-table because the z distribution was the standard normal distribution. And the standard normal is a normal distribution where the mean is 0. The standard deviation is 1. There we go. All right. There it is. It's called the z distribution. Alpha two-tailed test. We're going to go through these details, all of these details, okay? So I'm going to have you guys skip all the way down here to the procedure. It's at the bottom of the notes. We don't use the z-table anymore. And by the way, we're going to compute this, the test statistic. You're going to see what I'm talking about. In the past, that was just this, the test statistic, TS, we had a formula when we computed this. No longer, we're going to use the TI. So I just want you guys to know, we're going to look at hypothesis testing with the TI. Go all the way to the bottom because we're going to focus on this procedure. And you go, what's the procedure? Here is going to be our procedure. Okay? I'm going to have you guys focus on this here. Your first step is going to be to set up your what? Hypothesis. Okay? You're going to set that up. And then step 2 is going to be to create what's known as a decision rule. So if you look at this picture, here's what I mean by that. I'm going to outline this. It's your setup, right? And then over here is going to be your procedure. So your this is going to be where most of the work is. Step 2, right? Set up your hypothesis, create your decision rule. This is a two-tailed test. Now I'm going to mention to you, you might ask, how do I know it's a two-tailed test? Well, you're going to look at the alternate hypothesis. If it's not equal, you have a two-tailed test. So I'm just going to give you this outline. Step 3, you're going to see that we're going to take a what? Sample in step 3. Test 4, you're going to compute a what? Test statistic right in here. And the last step is to draw your what? You're going to have a conclusion step. Now, the good news is there's only two conclusions you're going to have. Either the sample is going to support the claim or the sample is not going to support the claim. There's only two conclusions. This is your hypothesis testing what? Procedure. So, ladies and gentlemen, let's try this out, okay? You guys ready for your first example to go through the details? So, it's not that hard, but at first, you first see the first example, you say, this is a long process. Well, maybe when you first see the first one, but after you keep doing it, it's shorter and shorter. Then, with practice, you can do it in your sleep. So, let's give you guys a good example to start with, okay? I don't know what you guys care about. Let's write down what you care about. What do you guys care about? What's that?
Life.
You care about what?
Life.
Life? Woo.
Like a game of life?
Okay. You care about life. Thank you. That's a good thing to care about. So that the proportion of college students who what? What do you guys care about in life? Anyone have an idea?
Essential,
Relationships.
no,
Relationships?
I was gonna say like essential necessities, like basic things you need to survive off.
And college.
Well,
Food, water.
the proportion of college students, should we keep it simple?
Like what?
Money.
Who favor in and out for lunch. That's kind of essential. Lunch.
Yeah.
Do you guys like in and out?
Yep, there's one near my house.
Which one?
One by Montebello. It was in a new plaza that they opened up.
You open up a new one?
Yeah.
You're talking here off the freeway next to Costco?
I've been there before.
It's pretty busy, isn't it?
It is.
Yeah, sometimes you can't even get in.
Nope.
Such a long line.
Such a long line. Dude,
It's usually on the weeks before 12.
Well, here's what I'm going to do. I'm going to share with you guys a hypothesis. This is as claimed, okay, by Snodgrass. So I'm going to give you guys an example here. We're going to try it out, okay? So the proportion of college students who favor in and out for lunch is 35% as claimed by Snodgrass.
Is that a fast food company or
What's that?
Snodgrass? Is that a fast food company?
No, that's actually some fictional person. I make up that name, Snodgrass, fictional person, okay? Because the thing about this, it sounds what?
Sounds like Pokemon.
Pokemon? Well, here's what I want to say. You first have to set up your hypothesis, but before you even can do that, you got to read the statement, translate it. We've been doing this. And I want to point out, this is a what? A claim by who? Snodgrass. Okay, Snodgrass. So let's write this down. This is an important part, right? You say P now is equal to 35%, and write this word down as the claim, okay? That's your claim. So the proportion of college students who favor in and out is 35%, as claimed by Snodgrass.
Snodgrass use proportion.
Okay, now here's what they're going to say. I want you guys to they're going to say here, a sample of 120 college students, okay, reveal that 65 favor what? In and out for lunch.
Is that 6.2 or 6S?
Hmm?
Right there, that it's right next to favor. Is that 6S or 6.2?
Where?
Oh no, that's 65. Never mind.
65.
Look like a
Yep.
guess.
Yeah. Yeah, it's 5. So they're going to say now use the 5% level of significance to test this claim. So you're going to see the questions look exactly like this. And I want you guys to jump to the end and say, they say what? Use the 5% level of significance to test this claim. Do you guys know what a claim is, by the way? That's a hypothesis. A claim is a hypothesis. %35%. So over here now, let's do the first part so you guys know. You got to set up your hypothesis. That was the first step that I gave you guys here. Step 1. Now you have H not H1. All right. Where in the world does that go? Where you want to place this, either as a null or as an alternate. Is it a null or is it an alternate?
No,
How do you know it's a null?
we can have, it has equality.
Yes, good job. That's how you know. Outstanding. Now, what is the logical opposite of equal? What's the opposite of that statement?
Not,
It's not equal. Okay, you guys okay with that? Okay, easy peasy lemon squeezy.
C.
That's what we call the setup. That's step one. So there's 5 steps. This is only the first step. I know people say, oh, this is long. Well, when you first learn it, it's not that bad. I think the first 2 steps are where most of the work is. And I'm going to go back and remind you guys something here. You see what I just did here, right? These 2 hypotheses must be logical opposites. So the opposite of equal is what? Not equal. You guys okay with that? That's the logical opposite. Either it's the same as or it is not the same as. So those are logically opposite statements. What you want to do now here is this, create a what? Normal distribution bell that has 2 tails. So this is something you guys are going to learn to do. This will have 2 tails. This is up here where you see not equal. This is going to be where you have the what? 2 what? Tails. Step number what? 2. So, ladies and gentlemen, in step 2, here's the deal. You see your bell that has 2 tails? The middle portion that's not shaded, you're going to always describe that region as do not reject the null. You're going to always describe it that way. Do not reject the null. Do not reject the null. And then your tail, in this case, there's 2. This is called the rejection region. Reject the null. Reject the null. Those are your tails. Again, this is going to be your what? Your Z distribution right over here. Here's Z. Okay? The mu equals 0. Sigma equals 1. This is your Z distribution, standard normal. All right? Now, the last thing we have to find is right here. They're called critical values. This is going to be what you guys need to know. We got to find what's called critical values. So 5% level of significance. Let me go back here, okay? This is alpha. And what alpha is really defined to be at this point for us is it's the total area in your tails. So on the left tail, you have what? 2.5%. On the right tail, you have what? 2.5%. Here and where? Here. You guys with me on that? I want you guys to know that alpha is the sum of the tails. So back here on the sheet, I said your procedure here, if you look really close now. Alpha over 2, alpha over 2. We need these 2 critical values. Okay? Because alpha is the sum of the tails. I'm going to write that down here. It's not that good to write, so let's do this here. Alpha is the sum of the tails here. All right, now you might say, Mr. Judge, how do we find those critical values? And once you do that, you're done with your decision rule. This is where the most of the work is, but it's not that much work once you've practiced. So what I want to say to you guys is this. You're going to use the TI calculator here, okay? And it's really simple because did you guys use the TI calculator on your test? Do you guys remember that? How many people have that older version of the calculator? Anybody? You guys have the older one? Okay, you have to use what's called the default, right? Anybody have the newer version? How many people have the newer version? Okay. Now, the reason I say this to you guys is this. You already know how to do this. This is 2.5% right over here. 0.025. This is 2.5%. The total is 5. You guys okay with that? .025. Okay. You're going to use, this is the last class. They had, some of those students want to see the old calculator. I'll put the new calculator, right? What you're going to use now, so they've already had a head start with some of these things. What you're going to use in the TI is inverse norm. You're going to use that inverse norm key. Do you guys remember that one? So on your test, you guys used inverse norm, and you said stat, distribution, inverse norm is number 3. So you're going to go to number 3. You guys okay? And now notice what you guys see here. There's an area field. Mu is 0, sigma is 1, and then you see what? The tail's left, center, right, and you might say, what do I use? Well, there's various things you guys can use. I'm going to do this. I'm going to put 2.5%, 0.025, and I'm going to say left tail. So you might say, why? 2.5% left tail. Here's the deal. You need a critical value here. 2.5% area to the left. Do you guys remember that default on the normal distribution working backwards? That's when you did inverse norm. It's the same thing. But it's now for the standard normal distribution where the mean is 0 and sigma is 1. And that's why I have left and 2.5%. So if you now hit equal, what does that give you? Go to the nearest thousands. What does that give you? Do you guys know? What is that? Critical value is what? Negative 1.9 what? 60. Is that true to the thousands? So you're going to use inverse norm, and in the way you did it on your test, because what's in the left tail is 2.5% of the bell. So there it is, ladies and gentlemen, right here. But because of symmetry, what's the other value? Anybody know? What's the other critical value? It's positive 1.960. So when you have two tails, you're going to have two what? Critical values right here. Okay, you guys okay with that? That's your decision rule. Shh. That's where most of the work is. I know when you first see it, you see that's a lot of work. It is. But you get used to it as you do more and more examples, and it comes a lot faster.
So it's just like, just comes natural the more you do
It will. Anything does the more you practice.
Very true.
That's the secret to success. Practice, practice, practice. And so we want to show you guys, this is the first two steps. This is where most of the work is. What I have to share with you guys now is this. This is where the sample information comes in, okay? What does it say? It says a sample of what? 120 college students reveal that 65 favor In-N-Out for lunch. Remember the estimation? This is exactly what you guys did for estimation. What does 120 represent? That's the sample what? Size. What does 65 represent? The number of successes. So here in your sample, the sample size is 120. The number of successes is 60 what? 5. All right, you guys okay with that? Now, you might say, okay, Mr. Judge, how in the world do we do this? Because this is going to be step number 3. Step 3 in the procedure was to take a sample, and then now we're on step 4, which is to do what? Compute the test statistic. But you're not going to use this formula. What are you going to use? The TI.
So we're on step 4 now?
You were on step 4. You take the sample. You don't really take a sample. What you do is you read the sample information. That's why I'm saying you have that here, okay? We just read that. That's like taking a sample. But now you go, wow, I'm going to test this claim by a sample. Step 4, you got to compute a test statistic. You might say, how do I do that? You're going to use the TI. And you might say, what do I use in the TI? We're going to use what? 1 proportion Z what? Test. So in that TI, here's the deal. We already got this. You're going to go now to this. This is stat test. I'm going to show you in your notes. You have it in your notes. Stat test. You're going to go to 1 proportion Z test. What number is that? 5. 1 proportion Z test. And if you see this, take a closer look, okay? I'm putting this in our lecture notes so you guys are aware. We're doing step number what? 4, computing that test statistic. It's 1 proportion Z test. And now we're going to have to enter the information here. So take a look. I want you guys to see, what does that first entry say? P naught. You go, oh my God, what is P naught, right? You see P naught? What is P naught? P naught over here.
Isn't it 35?
Yes, it is. How'd you know?
Because it says not from no.
Yes, you're right. It's right here, ladies and gentlemen. You're absolutely right. P naught is right here. It's the proportion in the null hypothesis. So here's your null hypothesis, H naught, and it says P equals 35%. There's your P naught. There it is, 35%. P naught equals what? 0.35, because that's 35%. So I write it down, ladies and gentlemen, because I'm going to have to enter that in the P naught field, 35%. You guys okay? So we're going to put what? 0.35 there. Now, what's the number of successes here? 65. What's the sample size? 120. Good. Is this a two-tailed test? Because that's what this line has to ask you. That's a two-tailed test. So if that is not equal, hit enter. Go all the way down to the word what? Calculate. So ladies and gentlemen, this is everything you have to enter. P naught, X, and two tails. Say that again. P naught, X, and two tails.
So two tails will be the non-equal.
Not equal, yes. That's the alternate hypothesis. So if you guys see this here in your TI, that's your alternate hypothesis. That's not equal. Now you just hit enter. And ladies and gentlemen, you see the second line?
Let's see.
Go to the nearest thousands. What is that? 4.40, what number? 2. That is your test statistic. That's what you need to find in step 4. It's your test statistic, 4.402. So where does that number belong on your decision rule? Anybody know? Where is it?
On the Z.
So this is what you're going to have to do now, okay? So here's what I want you guys to know. If your test statistic lies between your critical values in this range, it doesn't, but if it did, you would not you do not reject the no. We're going to talk about that language. But because that number you got is bigger than your critical value to the right, because it's positive, right? Because it's bigger than 1.96 over here, that's going to be 4 point what? 402. That's where your test statistic lives on the decision rule. It is bigger than 1.960. What neighborhood is that in? What do we label that region? Rejecting the no. Okay, let me say that again. The 4.402 is in the reject the no region. So after you compute the test statistic, you want to see where it lives on your decision rule. This is the procedure here. The last step is to state your conclusion. And you have two types. It says you're either going to say this: the sample supports the claim, or the sample does not what? Support the claim. It's one of these two statements. You say, well, how do I know? Go back here, right? We're almost done, ladies and gentlemen. I know. When the people see the first question, they go, oof. But then how does it get quicker? You do more and more and more, and then you do it in your sleep.
Nah, I just don't get enough sleep.
Okay. Can I ask you guys this? It's a sad question. Have you ever been rejected?
Yes,
Yes.
No.
yes. That's the hard part, yes.
Well, if you live long enough, you're going to be rejected one day. Okay, what does it mean to be rejected, right? You're going to what are you rejecting here? The null, H naught. So go back to your hypotheses, huh? Go back and reject your what? See this? Isn't the null gone? You just rejected the null. When you reject the null, you're accepting the alternate. Okay, let me say that again. Your test statistic is larger than that critical value, and it lives in the rejecting the null region. Get rid of the null, and getting rid of the null means you accept the alternate. However, what was the two conclusions that we said? Either your sample supports the claim or the sample does not support the claim. Either the sample supports the claim or the sample does not support the claim. Right? So, what do you guys know about that there? What just happened to the claim? The claim is gone, is that right? Because the claim is gone, what do you think we say? The sample, what? A picture's worth 1,000 words. I'll write it right here. What this means is, since you got rid of the claim, the conclusion is the sample does not support the what? Claim. Your sample doesn't support it. And there it is. You guys okay with that? Sample does not support the claim. Sample does not support the claim. There you guys go. Easy peasy lemon squeezy. Wow. First example is long always, but you have to get used to this procedure. It'll get shorter, and you go, okay, I think I kind of like this. But this is a very formal method. This is what's called the scientific method. And even though you say, but you gave me an in and out question. But, you know, we use hypothesis testing in other disciplines. And maybe you care about this idea. It's used in various disciplines. Okay, you guys okay with that? Let's give you guys another example. Or do you want a break? Should I give you a break or another example?
Another example and then a break.
Okay, good job. I like that. Another example, then a break. What do you guys think?
Let's go. Let's do it. I'm like running and fighting cells.
All right. The proportion of college students who believe in Bigfoot is not 50% as claimed by who? As claimed by Snodgrass. Good old Snodgrass. Didn't know say this. A sample of 250 college students, that looks more like a 5. Reveal that 108 believe in Bigfoot. So, okay. Use the 10% level of significance to test this claim. Here we go. The proportion of college students who believe in Bigfoot is not 50% as claimed by Snodgrass. A sample of 250 college students reveal that 108 believe in Bigfoot. Use the 10% level of significance to test this claim. Okay. Now, the first thing you always do is read off the claim. The proportion of college students who believe in Bigfoot, what is the claim? What do they say?
50%
Is not what?
is not equal
Yeah, and how do we actually know this is a claim?
because
It says it. It's claimed by Snodgrass. Okay, so let me write this down. What does this say? The what? The proportion of P of college students who believe in Bigfoot is not 50% as claimed by Snodgrass. So we're going to put P here is not what? 50%. And what is this? This is the claim. Where does that belong? Is that a null or is that an alternate? Where does that go, ladies and gentlemen?
an alternate because
That's what?
it's an alternate because it's not equal.
Good. You're right. That's right. Put it in the alternate position because it's not equal. You're completely right. Absolutely. Now, what else do you guys do? Do you guys know? P, 50%. What's the inequality now? Equal. Doesn't those have to be logical opposites? You gotta set that up. Is that right? All right, you guys okay with that? Okay, you guys okay with that one? Now, let's read this. What does that say now? That says what? Sample of 250 college students reveal. Well, I'm sorry. That is true. It does say a sample of 250 college students reveal that 108 believe in Bigfoot. Now, that means our sample size is what? 250, and our successes is 108, right? And then what do they say? Use the what?
Use the
10% level of significance to do what? To test this claim. Okay, so again, what kind of test is this going to be? It's going to be a two-tail test. How do you know that you have a two-tail test? See the alternate hypothesis? It's not equal to what? Tails. So what do you do? Here, here, two tails. Z distribution. Okay, so we're going to have to do the decision rule. Draw your bow. What in the middle? What do you say? Do not what? Do not reject your null hypothesis. And then the left is a what? Reject the null. And on the right is a what? Reject the null. You need a critical value here and here.
Isn't this step 2? Yes.
Yeah, this is step 2. It's your decision rule, but remember, what's alpha? Alpha's 10%, is that right? If you have two tails, what does that mean? 5% is in the left, 5% is in the right. Okay, you guys okay with that? But how do you get those critical values? Inverse what? Norm. Second distribution, inverse norm is number 3. What area do I use now? How about if we use the other calculator now? You say, Mr. Judge, can you use the other calculator? Okay. Second distribution, inverse norm. Oh, you got area here. What's the default? Do you guys remember? How? It doesn't give me the option of a left, center, or right tail. What do I do?
You work backwards.
Well, what's the default? It is 5% area to the left of that critical value. Do you guys remember that? For inverse norm, isn't that the default you guys use working backwards on the test? So 0.05 is 5%, mu is 0, sigma is 1. Paste that, and what do you guys get? What's this going to be? Negative what? 1.64 what? 5. So, ladies and gentlemen, there is your critical value. But there's 2. What's the other one because of symmetry? What is that going to be? 1.645. So you got a positive and you got a negative here. 2 critical values. Okay, you guys okay with that? Inverse norm. We're almost there. What do you do now? Step 3, take a what? Take a sample. They really mean read the sample, but in real life you would take that. What's your sample size?
250,
What's the successes?
108.
Okay, let's write that down. N is 250. What is X?
108.
What is P naught? What do you guys get over here? What's P naught?
Was P 10.
It's right here. Is that right?
Is that the, is it 50 or 10?
50%. And actually, we should put, let me go back here. You know what we should always put? The decimal representation. Because if you don't do that, your calculator's not going to understand what you're talking about. It's going to do everything's wrong. So, I don't know. Did we? No. Alpha's 10%. The sample proportion is right here, 50%. Let me take that back. The statement, the proportion P, who believe in Bigfoot, is not 50%. So that goes here. You guys okay with that? This is my point to you. P naught is the proportion in the null hypothesis, so it's 0.5. You guys want to definitely write that down, okay? Because in the TI, what do you guys enter in the TI here? What is that? What's your TI? 1 proportion what? Z-test. Alrighty. So let's use, you want to use the old calculator again? Stat test. What do? 1 proportion Z-test, number 5. Now, what is your P naught? 0.5. What is X? 108. What's the sample size? 250. Is this a two-tailed test? Hit not equal, and then hit calculate. What do you guys get?
Negative 2.150.
Yeah, our test statistic's going to be what? It's the second, it's the Z value, negative 2.150. You are correct. Negative 2.150. So, ladies and gentlemen, your test statistic is over here. Is it past the critical value? Yes, good. So I'm going to put that, I'm going to label it over here. I want you guys to see that. Your test statistic is negative 2.150. You guys see that there? What neighborhood is that in? You're going to reject the what? You're going to reject the null. Because your test statistic is out here. You're rejecting the null. Okay, goodbye, null. The null got rejected, ladies and gentlemen. And then if the null's rejected, that means the alternate is accepted. You guys okay with that? Rejecting the null means accepting the alternate. What does that have to do with your claim? What are you really accepting?
That people believe in.
You're accepting the claim? What does that mean? The sample what? Supports the what? The claim.
I need better sleep.
So, ladies and gentlemen, this is your second version of the what? Hypothesis testing, and it's a two-tailed test, just so you guys know. Okay? I know it's a long process, but take a look. Wasn't this a little shorter this time? It's going to get shorter, shorter, and shorter for you. So let's do this here, ladies and gentlemen. And let's give you guys a nice little break. You earned it. Okay? Let's give you guys a break. All right, so we're going to be back in about 15 minutes. This is your break. Here we go.
Let me go outside.
All right. Okay, ladies and gentlemen, we're back. We're going to try another one, okay? Do you guys want to try this one on your own?
Maybe.
Are you ready, you think?
Maybe. I'll try. I'll definitely try. That's the only way I learn.
That's right. That's why we have you do that, okay? So I'm going to do one here and say, okay. I'm going to change this. I'm going to say here the proportion of college students, okay,
So studious.
who prefer Chick-fil-A. I think it's Chick-fil-A.
Chick-fil-A. Oh, remember they called it Chick-fil-A?
They call it Chick-fil-A, but I had to look this up because this was an example in the other class. Because I guess it's right before lunch and everybody's hungry. So they want to do food examples. The proportion of college students per Chick-fil-A for lunch, we'll say, is 40% as claimed by good old what? As claimed by Snodgrass again. Okay. A sample of 500 what? College students reveal that 188 prefer Chick-fil-A. Use the what? 1% level of what? Significance to test this what? Claim. So I'm going to give you guys some time to try this on your own. And let's see what happens. All right, ladies and gentlemen, you guys ready for this? Here we go. The proportion of college students who prefer Chick-fil-A for lunch is what? 40%, as claimed by who? Snodgrass. Okay, you guys okay with that? So once I read that, you know what I think? Translate this. What does the translation become? Proportion of college students who prefer Chick-fil-A for lunch is 40%. Isn't that P equals 0.40? And isn't that the what? The claim? Okay, you guys okay with that? That's your claim. So when you set up your hypothesis again, where does that belong? Do you guys know where that belongs? That's a what? Is that a null or is that an alternate? How do you know it's a null? That's right, the condition of equality. Good job. There you guys go. Now, what's the opposite of that statement? Not equal to 40. What's that? Mm-hmm. Okay, now, once you set this hypothesis up, what do you guys do? Mm-hmm. Zero, here's the deal. Here's what I'm going to say to you guys. We say what? Do not reject the null, and then over here, what are you going to do with these? You're going to what? Reject the what? Null. You're going to reject the null. Easy peasy lemon squeezy. Now, you might say, let's read further, because if you do, it says a sample of what? 500 college students reveal that 188 prefer Chick-fil-A. So just reading this tells you the sample size is going to be what? 500, and your successes is 188. Is that right? So I might just write that down since I'm reading that paragraph. Sample size is 500. The number of successes is 188. Okay. And then what do they say? Use the what? 1% level of what? Significance. Alpha equals what? 1%. Okay. So since you have two tails here, that means half of 1 is 0.5%. So half is in each tail. You guys okay with that? And then 0.5% numerically is 0.0 what? 0.05. So when I find the critical value, which is what I got to do, I'm going to use that area to the left, that default. Because I'm going to have to get my critical values using, what do you guys use to get them? Inverse norm. Okay. So could you guys tell me what that critical value is?
-0.104 or 1.015.
Well, let's go. Let's try this out. Okay. Second distribution, inverse norm. And you get now point what? 0.005. What do you end up here with? What is this? Mm-hmm. It's negative 2.576. And then what? Positive what? 2.576. You guys okay with that? So you get negative 2.576 and you get positive 2.576. But that's how you guys get your critical values. You guys okay with that? Good. Okay, now we're almost there. You say, what do you mean? We're going to have to now get the test statistic. And you say, well, how do I do that? Well, we're almost there. We just need to know this is P naught. Okay. P naught is 40%. What does a TI say? We use 1 proportion Z what? Z test. All right, ladies and gentlemen, here we go. Sorry. So how do we get there? Do you guys remember? We have to go to what? Stat test 1 proportion Z test. What's your P naught? 0.4. What is X? 188. What's the sample size? 500. Go down here. This is a two-tailed test again. Is that right? Hit calculate and double check. It looks like, does it look like everything we need here? You guys see what I'm saying? Okay, if we hit calculate, what do you get? What's your test statistic going to be? That Z value is going to be what? Negative 1.09 what? 6. Oh, 5. You're right. It's 5. Good job.
Like 6.
I know. It's good. You guys are good. You guys are on top of it. Good. All right. Where is that going to be? Do you guys know? Is it past the critical value? No, it's not. Negative 1.095 is not past the critical value. And any test statistic value that is between your critical values, got to be between them. What do you say you do? Do not reject the what? You don't reject the null because your test statistic is between those two numbers. All right, you guys okay with that?
Good lesson.
Negative 1.095. Do not reject. So what does it mean not to reject? If I said to you, you see the null, don't reject it. What does that mean? It means you're accepting it. The alternate is really what? Gone. So when they say do not reject the null, that means accept the null. Because not rejecting is accepting. You okay with that? But what does that mean about your claim? Your claim happens to be the null, so what do you think the conclusion is going to be? The what? The sample what? Supports the what? Claim. So the sample does what? Support the claim. Easy peasy lemon squeezy, ladies and gentlemen. All right, now I want you guys to know here, if I go over to Canvas now,